In this video, we're going to look at the second type of factorising. We've already looked at how to factorise by taking a common factor, and now we're going to look at how to factorise a difference of two squares. Now, part of this is being able to recognise when we do have a difference of two squares. So the word difference here means a subtraction. If the difference between two things would be one thing, take away another. So the difference of two squares will always have a minus sign in the middle. The two part means there's only going to be two terms in a difference of squares, so one term and two terms. Same here, two different terms. And the squares part means each term has to be a square. So x is obviously a square here, it's x squared, and 9 is 3 squared, so that's a square. 25 and 16 are both square numbers, and obviously I've got a square and a square here as well. Now the first thing we want to look at here is it's ideal if we know our square numbers off by heart. So remember, when we square a number, it means a number multiplied by itself. So 1 times 1 is 1, so that's a square number. 2 squared is 2 times 2, which is 4, so 4 is a square number. 3 squared is 3 times 3, which is 9, so 9 is a square number. And I'm just going to quickly write out the rest here. And I suggest you pause the video at this stage and just try and quickly memorise these before going on to the next slide. Now we've looked at the list of square numbers up to 100, what we're going to do is we're going to try and identify which of these are a difference of squares. Now remember, for it to be a difference of two squares, it has to be a difference, which means it has to have a minus sign between the two terms. The 2 means there must only be two terms, and squares means both terms must be squares. So at the moment, I want you to write the numbers 1 to 14 in your classwork jotter, and then I want you to put a tick next to each number you think is a difference of squares, and a cross next to each number you think is not a difference of squares. So pause the video now, try that, and then press play when you're ready to check them. So we'll look through these quickly. The first thing I'm going to focus in on is the word difference. Now difference means we're taking away one term from the other. So any that have an addition sign in the middle can't be a difference of two squares. So number 2 and number 8 are both out because they both have a plus in the middle. They're a sum of terms rather than a difference of terms. The next thing we'll look at is we'll look at the 2 part here. Now 2 means there are two terms, like for instance here, one term and a second term. So there must be two terms in a difference of squares. So straight away, if I look at number 12 here, we can see there's 1, 2, 3 terms there, which means that is not a difference of squares. Now all the ones we're left with, they are all two terms, and they are all a difference. In other words, there's a takeaway between two terms. What I've got to check then is, are both terms squares? So we know our numbers are square numbers, and if we have a squared sign on a letter, that letter is a square as well. So this one here, we've got x squared take away 36, which is a square number. It's 6 squared, so that is a difference of squares. For number 3 here, y is clearly a square and 25 is 5 squared, so they are both squares. For this one, 49 is 7 squared, and y is got a square sign, so again it is a difference of squares. This one here, x is squared, but that 5, that's not a square number. Okay, so that is not a difference of 2 squared because the 5 is not a square, so we can put a cross there. For this one here, a little bit more difficult because we've got a term with a number and a letter. So the 4 is a square number and the x is squared. Now if both parts there are both squares, then the whole term is square as well. And the square root of 4x squared would be 2x. In other words, 2x times 2x gives me this 4x squared. So this term is a square, and we know 25 is a square number, so that's a difference of squares. For this one, we've got a squared sign on this letter and a squared sign on this letter, so we're good. That's a difference of squares. On this one up here, we've got x cubed. Now, because we've got the cube sign, this x here, this is not a square, it's a cube, so that's not a difference of squares, so that gets across. On this one, the 100 is a square number, it's 10 squared, and the y has a square sign, but the number multiplying it is not a square number. 2 is not a square number. So now, because the 2 is not a square, it means the whole term is not a square. So this is not a square here, so not a difference of two squares either. In this one, we've got the 16, which is a square number, it's 4 squared, and we've got the 25, which is a square number, and the x is squared. Now, because both of these here are both squares, then the whole term is a square. So that's a square, take away a square, which is the format we're looking for. For this one here, we've got a square, and we're taking away another square in this 4, but that x does not have a squared sign on it. Now, Even though the 4 is a square, because the x has not got a squared sign, it's not. So the whole term, therefore, is not a square. So this is not a difference of squares. And down here, we've got 14y squared, take away 16x squared. So because the 14 is not a square number, it means this term here is not a square. So again, that's not a difference of squares. Now that we've looked at what a difference of squares looks like, we can actually go into the easy part, which is doing the factorising. The harder part is actually identifying the difference of squares. So when we have a difference of squares, in other words, something squared, take away something else squared, what we can do in the first bracket is we can take the square root of a squared, which is a, and put it at the front of the bracket, and put it at the front of the second bracket as well. And then we can take the square root of the second term here, so the square root of b squared is just b, and we can put that at the end of each bracket. And then one bracket has a plus in it and one bracket has a minus. Now that'll make more sense when we kind of go on to the examples here. So first of all, check, is this a difference of squares? So I've got a square here and 9 is a square number and it's a difference, so this is a difference of squares. Now when it's a difference of squares, the first thing I'm going to do is I'm going to write it out into two separate brackets like this, and I'm going to take the terms in turn. So I'm going to, x squared is the first term, so the square root of x squared is just x. So I'm going to put an x at the front of each bracket. I'm going to then look at the second square term, which is 9, and I'm going to take the square root of that as well. Now the square root of 9 is 3, so I'm going to put a 3 and a 3 at the end of each bracket. And then for a difference of squares, it always has one plus in the middle and one minus in the middle. And that's basically all you have to do. Let's have a look at the next one. We've got 25, which is a square number, a difference, so take away there, and another square here. So this again is a difference of two squares. So again, when we've got a difference of squares, we're going to write out two empty brackets, and we're going to follow these terms in order. The order here does matter, so the 25 comes first. The square root of 25 is 5, so I'm going to put 5 at the front of each bracket, and that's because the 25 comes first, then the 5 should come first in each bracket. And then the x squared comes second, so we're going to take the square root of x squared, which is x, and I'm going to put it at the end of each bracket. So I'm going to put an x here and an x here. And with a difference of squares, you just need to remember one gets a plus, one gets a minus. Now, it doesn't matter which way around you put the plus and the minus, they can go either way around. So just bear that in mind when you're marking answers. The last one here, again, we've got a square number, 9, with this x squared, so that means 9x squared is a square. We've got 25, which is a square number, and we've got this y squared, and it is a difference. So again, this is a difference of two squares. So what we're going to do, because we know it's a difference of squares, is we're going to write out our two brackets. And we're going to follow these terms in order. So we're starting off with the 9x squared. Now, the square root of 9x squared, we need to take the square root of each part individually. The square root of 9 is 3. And the square root of x squared is just x. So the square root, therefore, of 9x squared is just 3x. That makes sense if you think about it, because 3x multiplied by 3x, or 3x squared, would be 9x squared. Now, what we do with that, remember, is that goes in at the front of each bracket. So if it's 3x at the front of the first bracket, it's also 3x at the front of the second bracket. We then move on to the 25y squared. So take the square root of each part again. Square root of 25 is 5. The square root of y squared is y, so the square root of this will be 5y. And it can go at the end of each bracket, because remember here the order is important. Because this 25y squared comes at the end, then the 5y should be at the end of each bracket. And remember again, with the difference of squares, one bracket gets a plus in the middle and one bracket gets a minus, and that's always the case. Again, remember the plus and minus can go either way around, and just bear that in mind when you're marking your answers.